Okay, let's talk about calculating variance for a specific probability distribution. So the problem we are looking at gives us the probability density function, or PDF, for a variable we are calling x. And that PDF is given by the expression p of x is equal to 1/2 times the sum of two Dirac delta functions. One is delta of x minus a and the other is delta of x plus a. Our goal is to find the variance of this variable x. We have a few options here. Is it a squared 0 to a squared or a squared over 2? Let's figure it out. To find the variance, we use a standard formula. The variance of x, often written as var of x, is calculated as the expected value of x squared minus the square of the expected value of x. So var of x equals e of x squared minus the quantity e of x squared. Remember, e of x is the expected value or the mean of x, and e of x squared is the expected value of x squared. We are given that the probability density function is p of x equals 1/2 times delta of x minus a plus delta of x plus a. Now we need to calculate e of x and e of x squared using this PDF. Let's begin calculating the expected value of x, which is e of x. The expected value is found using the standard integral definition, integrating x times the probability density function over all possible values. We substitute our given p of x into this integral expression. Next, we pull out the constant factor of 1/2 and split the integral into two separate terms corresponding to the sum inside. The key to evaluating these integrals is using the property of the Dirac delta function. The integral of any function, f of x times delta of x minus c, is simply f evaluated at c. Applying this property to our first integral, where f of x is x and c is a, gives us a. For the second integral, where f of x is 0, x is x and c is negative a, we get negative a. Substituting these results back into our expression for e of x, we have 1/2 times the sum of a and negative a. This sum simplifies to 0, giving us e of x equals 1/2 times 0, which is 0. Next, for step 2, we calculate the expected value of x squared, or e of x squared. Similar to the expected value of x, e of x squared is found by integrating x squared times the probability density function over all values. We substitute our specific PDF into this integral. Just like before, we pull out the constant 1/2 and split the integral into two parts. We use that same property of the Dirac delta function. Here, the function we are integrating is x squared. Applying the property to the first integral, where the delta function is centered at a, gives us a squared. For the second integral, centered at minus a, we get minus a squared, which is also a squared. Substituting these results back into our expression, we have 1/2 times a squared plus a squared, which simplifies to a squared. So the expected value of x squared is a squared. Now step 3. Let's calculate the variance using our formula. Remember, the variance of x is e of x squared minus the square of e of x. Var of x equals e of x squared minus the quantity e of x squared. We just calculated e of x squared to be a squared and e of x to be 0. So var of x equals a squared minus the quantity 0 squared. 0 squared is just 0 squared. 0 squared is just 0, so var of x equals a squared. So based on our calculations, the variance of x is a squared. Looking back at our options, this matches option number 1. The final answer is a squared.